So in this part of the lab, what I'm trying to do is I am going to show you an example of mediation analysis, and the algorithm or the steps of the mediation analysis is as described in the lecture with respect to the weighting approach. I'm not going to show the mediation approach in this particular video with the imputation method, but I'm just going to focus on weighting approach, and that will probably give you enough understanding to do the mediation analysis using the weighting approach. So in this lab, we are going to use osteoarthritis as the exposure variable, and we are going to use the cardiovascular event as the outcome variable, and A is the osteoarthritis, Y is the outcome, and the natural direct effect is the effect between A and Y directly, and natural indirect effect is basically the effect of A that goes through M to Y, right? So remember in the lecture we talked about our step 0. We want to build the data first, and this is the original CCHS 1, 2, 3 pain data using the CCHS 1, CCHS 2 and CCHS 3 datasets. And in this example we are basically going to use age, sex, income, race, BMI, education, physical activity, smoke, fruit and diabetes as confounder variable, right? In other examples we have used physical activity as another mediator, but in this particular example we are just going to use these as confounders. And this pain medication is our main mediator and the only mediator that we are going to consider. OA or the osteoarthritis patients are going to be our exposure, and cardiovascular events are going to be our outcome. So at the beginning of our analysis, what we are doing is we are converting all of the character variables to numeric variables. See what we are doing here. So this was originally a character variable, yes or no. This was originally a character variable OA and control, and this was a character variable or factor variable using event and no event. We are basically converting them to 0, 1 using this if else command. Alright, so we are at step 0, remember, and then before we run our step 1 and 2, we are just going to skip over and run something else for later. So we are just doing it because in the step 1 and 2 we are just going to change some of the data aspect. So before doing any manipulation on the data, just to be clear on what we are doing, I'm just going to run the mediation model in this particular step. So in the lecture you remember that we talked about how to use or how to perform a mediation analysis in the survey weighted data. So it is not really clear from the literature whether in the mediation model, when we are building our mediation model, we need to do survey, we need to properly set up the survey weights. But of course in the outcome model, when we are building our outcome model, we need to build the survey weights into creating our design, right? So there are a couple of suggestions of how to deal with it, and similar to propensity score, we can either work with this mediator model. When we are building our mediator model, we can work with a dataset, not the design, right? So what is the difference between the dataset and design? In the design we are essentially taking into account of the survey features, and in the dataset we are not really taking into account of the survey features. So we could do that, but in this particular example I'm just showing you how to work with a situation where we are also converting our dataset to design to build the mediation model, right? We could do it just to be clear, we could do it without the survey features here, just by using the GLM and using a data. All right, so now that is out of the way, we could go either way, but in this example I'm choosing to work with a design. So what I do is I define my design using the whole dataset, and then I restrict my design with the complete case data, because in this particular example I'm not really imputing any data sets to deal with the missing data problem. And then we are building a mediator model that we will use later in our step 3, but we are just building this model at this stage so that it is it does not get lost when we perform our step 1 and 2. All right, so this fit AM is our mediator model, where we have the mediator as the outcome, and we have the exposure, and we have all of the other confounders. But what is this exposure temp? Was not our exposure just the exposure variable? We define exposure as exposure temp in this particular data set, the analytic miss, and that reason will be better understood why we defining a temp variable in our step 3. Alright, so when we fit our mediator model, we can see this is the exposure variable, and that is coming out to be significant. The odds ratio is 2.47, the relationship between the exposure and the mediator after adjusting for all of the other confounders, so that is pretty high. Alright, so this is our original data set with missing values, and this is the original data set without the missing values. That means this is the complete case analysis, and the difference is this: we are essentially deleting this amount of people, right? So remember what was our step 1 and 2. In the step 1, we basically duplicate the original exposure variable, right? So what we are doing in our step 1 is that we are basically creating 2 copies of the dataset. This D1 is the, say for example, the fact data, what happened, and this D2 is the alternative fact data, that whatever did not happen, right? And we are basically copying our original dataset into these 2 new datasets. And in the first dataset, what we are doing is that we are defining our exposure counterfactual variable with the original exposure variable. We are not changing anything. Whatever happened in this dataset's exposure, the same thing is happening with this dataset's exposure, this exposure variable. So you can call it the exposure or A, and you can call it the A star variable, as I have explained in the main lecture. And then in the second dataset, this is D2. In the second dataset, what we are doing is that we are putting an exclamation sign. This means that if your original exposure variable was 1, 1, 0, when we put a exclamation sign, it will be 0, 0, 1. That means what? All of the treated subjects will be converted to control subjects. All of the control subjects will be converted to treated subjects. And this is happening in the second data set. So this is the A star variable that we have seen, and this exposure was A variable in our original lecture. Then what we are doing is we are basically appending both of these data set, D1 and D2, and we are creating our new dataset, new D. And then we are doing some internal calculations, such as we are ordering the dataset with respect to our ID, so that all of the IDs, all of the rows associated with the same IDs are going to be together. All of the row 1 and 2 will be associated with subject 1, row 3 and 4 will be associated with subject 2, and so on. All right. So this is done. In the first step, remember what we have done? In the first step, we have selected which variables should be in our dataset. in the second step, what we have done is that we have created our A star variable, and we have created two different datasets, D1 and D2, and in there I have created this A star variables, and then I combine those datasets into a new D. Okay, so as I have explained earlier, I'm just going to explain the weighting approach. So in the weighting approach, what I'm going to do is I am going to use the preset model that I have fitted here. Remember this fit M model that we have fitted earlier? We are just going to use that fit M model. Where? In the step 3. So what I am basically going to do is I am going to estimate the probability of getting the mediator variable given the exposure status and the confounder status. That means what? That means I am basically predicting the probability of taking the pain medication given that exposure variable as well as the confounder variable. And see that this A variable is the original A variable. We are not really changing the A, but in the second model when we are fitting, we are going to again find the probability of getting the pain medication given the A star variable and that C variable. So in this case we are going to change the A to A star, right? What did not happen. And how we are going to get this probability? So or the model was the same, whatever model that we have fitted in our fit M. So this is the model that we are going to use. See what was our exposure temp. We are not really using the exposure, we were basically using the exposure temp so that we can change our exposure temp. How? This is what we are doing. We are essentially defining our original A variable to the exposure variable, and then when we are using this entire data new D, remember what was this new D? New D was the combination of this D1 and D2. We're going to use this new D data to get the predicted values. And once we get the predicted values, in here W is denoting the predicted values, we are using this formulation that if the mediator is 1, then assign W. If the mediator is 0, then assign 1 minus W. And that will define our denominator of this equation, this PM given A and C. So this is the denominator we are defining here, and then we still need to work with the numerator, right? So what we are trying to do here is that, remember in the numerator we have A star. See, there was the A star there, and for that we first need to change our exposure temp variable to the exposure counterfactual variable that we have defined earlier in here, and then we are essentially going to use, after redefining our exposure temp, we are essentially going to use the new D, the dataset that was a combination of D1 and D2 as the new data to predict from the fit.m to get our predicted values of W. Then we are again using the same formulation of using the mediator to determine whether a person should get a predicted value of W or a person should get a predicted value of 1 minus W, and that will form our indirect version of the probability. So we get the numerator from the indirect and we get the denominator from the we get direct from the denominator, right? So what we are going to do is we are just going to estimate this mediator weight. And how we are going to estimate this mediator weight? We are just going to divide indirect by direct. So we are just going to divide indirect by direct, and this will give us the mediator weights that we have defined here. And we can summarize the mediator weight. It can go from 0.4 to maximum 2.2. But see, you are getting a lot of missing values when you are getting these mediator weights. Why that is the case? Because remember, when we were defining our new D, we were using D1 and D2, but D1 and D2 was calculated or just the copies of the analytic miss that had a lot of missing values, right? And we had a missing data indicator. What was the missing data indicator? Our missing data indicator was miss equal to 1 was missing data indicator, and miss equal to 0 means that there was no missing values associated with that row. So miss had two values, 0 and 1. And then we find all of these not available values in our mediator weight, and we need to investigate where are these not available values are coming from. So we will see a bit later that these NAs are coming from the missing part of the new D variables. None of these missing W's are coming from the complete case data, right? So that part we will see a bit later, but first take a look at the other portion of the weight. What was the other portion of the weight? It was the survey weight. So in this particular data, weight was defined as the interview weights or the survey weights, and we can see there was no missing value in the survey weights. All right, and this is basically the summary of the survey weights. It can vary from 0.39 to 2300, and then we multiplied the mediator weight with the survey weights, and we again see the same number of missing values that we have seen for the mediator. So every missing values were coming from the mediator weights. And then when I tabulate whether any of these missing values were coming from the complete case data or not, and we can see there is only one value, 1. That means all of the missing values were associated with the miss value of 1. And remember, what was the miss value of 1? It meant that there was a missing observation. So there was no observation from complete case that was associated with a missing weight. So all of these missing values that you are seeing in your weights are basically coming from the non-complete data set. From the complete case, there was no missing values. All right, so I don't really care whether there was any missing or not, so I can add I can definitely assign a 0 value, so that when we are defining our design, this does not really create any problem. So essentially all of these weights that all of these missing weights are not going to be useful for our further analysis anyway, because we are going to restrict our analysis to complete case in this particular lab exercise. All right, so that was a bit of an explanation of from where we are getting these missing values. And then we summarize, and we can see the minimum is 0 and the maximum could go as high as 300, more than 3,500. And this is because we are multiplying survey weights as well as the mediator weights, and you can see the distribution is pretty skewed. And then once we are done with our weight calculation, then we essentially do the step 4, where we are essentially fitting the outcome model with A and the A star and the adjusting for the confounders. So we again work with the design for the complete dataset. We are not really restricting our dataset to complete case here. We're working with both D1 and D2 with wire associated with many missing values. And then once we set our design, we then set to miss equal to 0. That means we are only restricting our complete case datasets. And then what we do is, this is our outcome, this is our outcome Y, and this is our exposure or A variable, this is our A, and this is our exposure counterfactual or A star, and these are all our C variables, right? And we are doing it in a design. And then from this fit, we are essentially going to get the odds ratios for exposure and the exposure counterfactual. That means we are going to get the odds ratio of A and A star, right? So how do you really get the total effect? The total effect is basically going to be the exponentiation of theta 1 and theta 2. What is this theta 1 and theta 2? Whatever is associated with our A and A star. What is the direct effect? Exponentiation of our theta 1. Whatever is associated with A. Whatever is associated with A star is theta 2. So exponentiation of theta 2 is going to give us our indirect effect. Alright, so in our context, when we have our fit, we can easily calculate our total effect using this exponentiation, and we are getting the total effect of 1.544. When we calculate the odds ratio associated with the A, we are getting the direct effect of 1.48. When we calculate the indirect effect, whatever is associated with the A star, we are getting 1.03. And we are again using the product rule of odds ratios, and this product rule should give us the total effect, and our total effect by this product rule is 1.55, and see 1.55 was our total effect when we calculated this. And the proportion mediated is basically going to be the log odds of indirect versus the log odds of the total effect, and that is going to give us the proportion mediated. In this case, it is only 8.5%. Alright, so there was a bit of process involved from step 0 to 4 to do all of this mediation analysis, right? So one could imagine that you can potentially write a function that does all of this, and you do not have to go through each of these steps one by one. But before using the function, you have to be very careful in understanding what was going on in all of this process. Alright, so say I write a function, do effect decomp, and that function only takes the dataset, and you have already specified which is the mediator, which is the outcome, and things like that within the function, and that will directly give you the direct effect, total effect, indirect effect, and the proportion mediated. And this function is also provided at the very end in the appendix. If you want to see and investigate the function, you can see that. One question can be, why do I really need to write this function when I can simply do the analysis in a step-by-step fashion, right? The reason is that the confidence interval that you are getting using this fit is not going to be very useful, because we are essentially using duplication of the data sets, right? One data was duplicated twice, and that's why the confidence intervals that you get out of this regression, or the standard errors that you get out of this regression, are not going to be very useful. So what do? You have to do Bootstrap. But to do Bootstrap, you need a function so that you can simply plug in your function and the Bootstrap will take care of all of the analysis steps within each of the replications. So that is why you need to write this function. All right. So how do you work with Bootstrap? In the Bootstrap, you simply name the function and you simply mention all of the other arguments within that function, and you say I want to do Bootstrap for 5 times. And if you have a computer with many cores, you can even parallelize the system, mentioning how many cluster you want to use and things like that. So for my case, for this particular lab exercise, I'm just going to stick to r equals 5, even though this r equals 5 is not going to be reliable for giving me a proper confidence interval. In real application, maybe try at least 250 and even more if possible, if you have enough computation support. So with just this 5, we are just going to pretend that this is our reasonable confidence interval, and this will give you all of these confidence intervals for all of these parameters that we are trying to estimate. Remember that we have 4 different parameters, so we are using 4 different index when we are estimating the Bootstrap confidence interval, and that will give you for 5 replications only. These are the Bootstrap confidence interval, and these are the total effect. And similarly, you can do it for the direct effect, indirect effect, and the proportion mediated. All right. So if you want to see the confidence interval in a plot, you can see this is the total effect, this is the natural direct effect, and this is the indirect effect. All right. So one other thing that I described in the lecture was that if you want to include some of the interaction terms and that are biologically plausible, that makes your model specification a bit more realistic maybe. And how do you really do that? So I have written provided here another function, and I should mention that these functions are already provided in the supplementary material of the reference that I have mentioned at the end of my lecture, and I have just made some few modifications in the function to make them work for the survey data analysis. And you can specify that function with the interaction, and that includes the physical activity and diabetic interaction in your mediation model, and that function automatically gives you this total effect, direct effect, indirect effect, and you can see the confidence intervals that you generated out of this Bootstrap in the same way you have generated the Bootstrap in the previous example. Right, and in this appendix you can basically take a look at the function that does all of these steps one by one. If you are trying to use your own mediation analysis, then all you need to do is you need to be very careful about changing these variable names to proper names, and then it should potentially work if there are no other additional problems in your dataset. And similarly, when I was talking about the interaction term, you can see that I have mentioned a very specific interaction term in here, physical activity and diabetes. So if you are looking for interaction term for any other covariate in your own analysis, just mention them here, and you do not have to just stick to this one interaction. If you have many other interactions, you can also include many other interactions in this mediation formula. All right, so that concludes this particular lab.